this would split it into the words that are the string. Is this clear? Are you with me?
So can you give some examples? I'm kind of confused.
Sure. So, for example, if you let S be equal to something, so let me say \t, which is a tab, something, or the other, and then a new line. Correct? This is a string. You do S is equal to, and suppose there is also a tab here. Correct? So S is equal to S dot R strip. This would with a new line, correct? This would remove the new line and return this string. Correct? So S would now contain this. Now you do so L is equal to do L is equal to S dot split, and this would give you a string. This would put L is equal to something or the other. Right? Is this clear? Hello? Can you hear me? Okay.
Yes, sir, we can hear you. Network slightly.
Sorry?
We can hear you, but your internet might be slightly unstable.
The internet might be slightly slow or something. I'm at CMI, so it should be fine. Anyway, so yeah. Okay. So having said that, I move on to something else. Correct? So I described some useful functions for strings, and before that we had talked about file IO and so on. So that's how to deal with strings. Now we move on to something totally different, which is abstract data types. Or ADTs. I guess you have seen examples of these in Haskell, but let me re-emphasize what must have been taught in Haskell, correct? So if you want to specify some data type, a new data type. So what is a new data type? First, let us look at the existing data types we had, like dictionaries or lists, or things like that. Then you have a bunch of functions associated with each one of them, and that's the only way to access this data type. So in dictionary, I mean, the number of functions might be very large, but what are some of the prominent ones? So you can, in dictionary, there is a way to initialize it by saying D is equal to this, and then there is a way to say D of K is equal to V, D of a key value is equal to V, and so on. Correct? And you can do things like d dot keys and so on. And similarly, in lists, you say L is equal to empty, or a pre-initialized list, you say L of some integer I is equal to V, and so on, correct? So with each of these, there is some interface available, correct? And you want maybe to define a data type of your own which has a similar interface. For example, many of you would know what stack is, or all of you would know what stack is, correct? So need I go into the details of stacks first, or you have seen, all of you have seen it in Haskell? Have you seen it in Haskell?
Yes, sir.
Okay. So what are the functions associated with the stack? You have push, you have pop, and at the very least, you have so you have is empty, is the stack empty, or and maybe a function called
Sir,
tell me.
so you said interface between two things earlier. You said when you want to define new data types, you want to define your own interface. Interface between what and what?
So yeah, so let me give an example first, and then I will get down to particulars, correct?
Okay.
Okay. So think of a stack, correct? How do you access a stack? Via these functions. So empty creates a new stack. Push puts in a value in the stack. Pop extracts a value in the stack, and is empty tells you tells if stack contains or does not contain an element, whatever. Not contains an element. Correct? So now you do not need to know or care about how the stack is implemented. You just need to know these four functions, correct? And ideally, the user should be given access only to these four functions in order to access the stack. Correct? Are you with me? These completely define the stack. So implicit in them is an understanding of what these functions do. For example, push so this is how we represent a stack, an empty stack, and push pushes in a value here. Pop extracts a value here. Is empty tests whether this value is there or not. Does there exist this value, correct? And empty creates a stack, an empty stack, correct? So you can think of this, and you know how to implement them. Implementing these using lists is very simple. For example, how would you, if you implement this as a list, how would you implement push? Tell me. Suppose you want to implement def push v, correct? And you have a list somewhere, list here, in which you want to store the stack. Then to push, you would just say L dot append v, correct? Are you with me?
Yes, sir.
And similarly for pop, you would say something like v is equal to L minus 1 and del L minus 1. Somehow magically del L minus 1 deletes the last element in L. Correct? So it's a strange syntax, but in Python, del L of I deletes the ith element. Correct? And then you return v. Correct? And similarly, you can define is empty, so on. Correct? So empty would be def empty. The def empty is somewhat of this thing. So you would say L is equal to empty. But now, how would you? So this would create one stack. Correct? Now suppose you want to create.
Is there a data type in stack, or like we just use it through lists?
So that's what I'm trying to emphasize, that you can of course implement these functions just like standalone functions, correct? You can say correct, something like this, correct? But now suppose you want another copy of the same stack. Another option is to define it, the same functions, you copy them and define them with a different L, correct? So to define another stack, you could say this and replace every copy of L by L1. So you would define firstly push one, L1, pop one, L1, L1, empty one, L1, something like this, correct? So, but this is clearly wasteful, correct? So what you want to do is to define a data structure, what is called an abstract data type, and implement it using functions. Implement it using functions and other inbuilt data types, correct? So how do you do that? Well, the way to do it in Python is to declare a class stack, correct? This creates a data type which is called stack, and inside that you define these functions. So so, and I'll have to make some certain changes here, but the basic outline is the same.
Excuse me, sir.
What I will do is now this I would have to tell me.
Sir, your voice is breaking off.
Hi, can you hear me?
Yes.
Yes, sir.
I don't know why it went offline for a second. Correct? So now, so I'll have to make some changes here. So firstly, I would have to introduce something called self.
So I don't think your screen share.
I don't think you're sharing screen.
Okay, one second. Thanks for telling me. 1 second. Now now is it visible?
Yes.
Yes.
Okay. So I added this argument self in each of these functions. I'm going to add this argument self in each of these functions. So what does that indicate? Self refers to the current instance of stack. Correct? So this one I'm going to leave, and then I'm going to access the L of self. So everywhere where I have L, I will replace it by self.L. Correct?
So does self mean
And
that the function is defined only on stack on that particular class?
so it means that it refers to the current instantiation of stack. So just give me 1 more minute, and then I will. So let me redefine this empty completely in a very obscure way for those who have not seen it. But then I will answer your question.
Okay, sir.
Correct. So now the point is, how do we firstly use the stack in the program, and how do you use it? So what you just say is, for example, you can say S is equal to stack. Correct? What does this do? This calls the function, calls this function, and returns a stack in S, an abstract data type, an object of this abstract data type stack in this name S. Okay, that is the value returned. And inside that is contained a list initialized to empty. Correct? And now if you say S dot push something, then the corresponding function push will be called. So here this self now stands for this S. So the first argument, this first argument is identified with self. Correct? Do you see my point? The first argument self is always is what you call with the push method or with the pop method. So you apply the push method to self. Am I making sense? So it's as if you have this so it's as if you have this template for stack, correct? And when you say this, you are creating an object of type stack, correct? And then you do operations on this object. So S contains a value which is an object of type stack, correct? So S contains value is an object type stack that we have just defined, correct? Via this class stack and so on, correct? And now what does
Sir, I just had a question. So, because at the center of everything, we've defined stack, like the self.l is defined as an empty list. Do we
yes?
get all the other functionalities of lists? Like, say we define stack like this, do we get to do other stuff that
So,
we
so that's
had?
a very good question. Ideally, you would not like the user to be able to do anything on the list other than what is prescribed by these 4 functions, correct?
Yes, sir. Yes, sir.
You would not want him to do something like self.l dot L something, correct? L minus 1, L minus 2 equal to 3, correct?
Yes, sir. Yes.
But in Python, there is no way, as far as I know, or in the basic Python, there is no way to prevent that. It is allowed, and yet, so the user is expected not to transgress um, the functionality laid out via these methods that are exposed to. So it's as if you have this interface, and this contains these 4 functions: push, pop, whatever, initialization, and is empty. Correct? So init is just to create this, so I should not be writing it here. To create it, you use init, correct? And thereafter, you can only operate this object via the knobs provided. These are the knobs provided. It's as if you have a radio device or something, and these are the knobs provided for you. You can only operate the device via these knobs. But like someone pointed out, it is possible to break that and go inside the code and change things, correct? Meaning even externally, you can say self.l minus 2 equal to 3 or something, which would change the integrity of that stack. But it's not, it's allowed, but not encouraged, correct? You agree with me? Do you get me?
Yes, sir.
Okay. So, so these objects, so this is one way of doing, or this is the way to do object-oriented programming. So you create these templates which will specify how objects will look like, and you program the template, and then you create objects of that template and use them, correct? So this is an example of object-oriented programming. And there are other aspects to it. Correct? So all the interfaces are public. All the functions that you define, all the methods you define are public here, correct? And yeah, so there are ways to sidestep these, but yeah. Okay, so another use of this is that what if you want to start this stack with something which is already there, not the empty list, but you want some other value which is non-empty. So another way to do that is to specify an optional argument there. So I will, how should I do it? I'll just write another definition of init here. Def init, self, comma, L, which is the initial list, and you say you can, for example, make use of the optional argument thing that we talked about in the other class and give an optional argument L equal to empty here and say self dot L equal to L. Correct? So if you don't specify this last argument, it will take it to be an empty list. And if you specify it, it would take it to be whatever you specify it with. Correct? And if you don't give a list, you give a dictionary or something, then it will give an error at some point. Or, I mean, if you give an incompatible type, it will give an error at wherever that incompatibility is detected. Correct? And in particular, if you think of a list as with the top of the list being, so depending on how you want to initialize your thing, so you might say L dot reverse and give that as the argument. Why do we want to say L dot reverse? Because something like 1, 2, 3, we might conceivably store it as 3, 2, 1, correct? So with it, I mean, this is not a good way to explain it. Suppose your stack from the stack top look like 1, 2, 3, correct? So you want to add at the one side, but if you just store this, as initial list this, then you would have to reverse it, correct? First, before inserting it. Are you with me?
So could you repeat the example?
So the example is this. Suppose you have this stack. You want to initialize this stack, correct? By a list which looks like 1, 2, 3, correct?
Yeah.
Then 1 is on the head side, on the top of stack side. So this is where the top of the stack is. Suppose this is your semantics, correct? The list, the top of the stack is near the beginning of the list, is at the beginning of the list, correct? Then you would first have to reverse the list and then start the thing. So you would say L dot reverse, self dot L is equal to L dot reverse.
Oh, okay. No, so pushes it from the back, is it?
Pushes it on, so always on one side, and that one side is towards the end of the list, correct?
Yeah.
Remember, we are appending this. So it pushes it at the end of the list. But here you want the stack top to be 1, correct?
Yeah, so I
So,
understand.
Yeah.
so why is L equals empty list a parameter?
Why is L equal to empty list a default assignment?
Yes, sir.
Because usually the most natural initialization, so if you just say S is equal to stack, what is the stack you would start out with? Most naturally, you would guess that it is initialize the stack to consist of to initialize the stack to an empty stack, correct? There is no other data available.
So if L is not given, it will automatically take L as
Yes,
none.
this is the default argument. So when you specify this in the argument list like this, L is equal to something. So when you do a def function A, B is equal to value, correct? Now, if you call this function with fn a only with one argument, we saw this earlier, then the argument b is replaced by val. I mean, the val is given to the argument b. It's like you're calling, this is equivalent to calling function a comma val. You see my point?
Yes, I think so.
Okay. So these are default arguments. And here the natural default is the empty list. So we are in fact defining two functions in one shot, one with just one argument self, and the other with the self comma this thing and L, and we do it in one shot. Correct? Okay. Having said that, so are there questions about stack and so on? Or about abstract data types?
I did not understand what init represents.
Okay, init represents, so that's a good question. I should have said it earlier. Init is the an inbuilt function, meaning not an inbuilt function. It is an inbuilt, it's a keyword that you specify in every class so that you can so that it is used as an initializer. When the function is called, when the object is created, s equal to stack, correct? When you say s equal to stack, a stack is created. And the init is used here. This init is used here. Correct? It's like saying something like s.init. So instead of saying stack.init, for which there is no syntax directly, you say s equal to stack. This uses this initializer, which is defined inside the stack function. Are you with me?
Yes.
Is it clear?
You said that s equal to stack, which bracket is similar to, I mean, like similar to s dot init, right?
No. It uses the init to populate a value in S. S is a name, correct?
So
It's a variable.
a function is being applied, right, on S?
Yes, this init is being not on S. It is initialized and the value is returned in S.
Okay.
Right?
Is it like something like a constructor or something? Default constructor?
It's a constructor, exactly. It is a constructor.
And in a class, does the Python interpreter searches for main method, something like that in a class control, like Java?
Main method? No, there is no main method per se.
Okay.
As far as I know, there might very well be an.
And the control first comes to init, right? If init is given, the control first comes to init.
No, this is just a template, correct? Now you use that template somehow by invoking it in your code.
No, I mean, if a list is not initialized, then how are we pushing in it in the like we define push in the
Yes,
at first, then pop.
You just define it. You can define it in any order. It is only when the code is executed. When the code is executed, how would you execute it? You would say class stack blah 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 blah. Then you would say s is equal to stack, and that would create a stack using init, and then you can do s dot push.
Okay, so when I call this stack method, the init is executed as creating the stack.
No, only when you call this s is equal to stack.
Yes, calling the function. So calling the class actually. Okay.
Yeah. Calling this constructor, when you call this constructor stack, only then a stack is created. Okay. And you can do also, you can create many stacks, you can create a list of stacks, whatever you want to do with it, correct? This constructor is called as many times as you create a new object of type stack. Correct?
So when you
Tell-
call this class function, then the init function will create an object of that class,
Yes. Yes.
and the name of that object will be the name that we use. That s if we use s equal to the function, then the name of that will be s.
Yeah. So you create a value,
And to refer to that
and
object,
it
we
will be
use the
stored in the name.
Okay. And then to refer to that
you
object.
create a value which is a sorry, 1 second. So you create a value which is of type stack, an object of type stack, and
Okay.
store it wherever you wherever this is in the name the s equal to stack, then it is stored in the name s.
Okay. And so self is
And
used
you
to
can-
refer to the object.
Self is used to refer to the object. Yes, exactly.
Okay. Please.
Self is the self-reference to the object inside the template for that class. Correct? So, otherwise, how will you refer to yourself? How will the object refer to itself inside the function definitions? This is the way to refer to the instance of the object, that object itself. Correct? Are you with me?
Yes, it's clear.
Okay. More questions? Okay. So let me move on to a slide variant, which is something which you can do with abstract data types. Correct? So right now we have seen a stack which consists of finitely many fields, and it is just to encapsulate the data contained inside a stack. That is the example we saw. But we can also use it to encapsulate recursive data types. Correct? What is a recursive data type? For example, a list. What is a list? A list is either empty or consists of value and a list. Correct? So basically a list is either an empty list or it contains a value and then the rest of the list, another list. Correct? Which could be empty or could consist of a value and another list, and so on. Correct? So I guess in Haskell you represent this by saying that you have x1 colon x2 colon xk colon nil. Correct? Or which is a shorthand for x1 colon x2 colon x3 colon something like this. Correct? Xk colon nil and then this. Correct? In Haskell. Correct? This is what a list is. Am I correct? So you can make this explicit in Python also. Correct? So you can say, you can define something like class my list. And what does it consist of? So we just saw how to define classes. So let's define an init function, def init self. Correct? And how would you define it? You would say let's say with a value v equal to none. Default value is none. So you would say self dot value is equal to v. Self dot next is equal to none. Correct? So what does this mean? It is saying that you have this list. There are two fields, v, value, and next. And the next thing presumably points to another object of the same type. So v prime and this. So it is basically the same idea as this. The only thing is we have
So, sorry, could you explain the diagram? I didn't understand the pointers. The pointers.
So here we say self dot next equal to none, correct?
Yeah.
So when you initialize it, it would initialize to v, and if we represent none by this, then this is the list. Now we have to say things like append, correct?
Yeah.
So this is an incomplete representation. So let's define it. Def append. So I will not go into append in great detail, but how would you append something to this list? This list. You would first create. Suppose this is some v1, and now you want to append v to it. So you would create via the init thing a new object which contains v, correct?
Yeah.
So this is what this init does, correct? So far we have seen this, correct?
Yeah.
And then to your list, you would remove this part and instead put a pointer, make whatever is contained in self.next to this object that you have created.
Okay, yeah, sir.
Correct? So you would say, so how would you say it? Suppose you were at the end of a list, you would have to say, so I'm not giving the complete code, but you would say self.next equal to, is equal to my list. Correct? And what is this dot dot dot? This would entail going to the end of the list.
Okay, yeah.
So how would you go to the end of the list? Let's fill in the ellipses here. So there are two cases. So if self dot next equal to so let's say if self dot next is defined, then what do we do?
Sorry, sir, I didn't understand the question.
So the question is, suppose we are in a long list, v1, this is pointing to v2 and so on, correct? Suppose now this is empty, correct? And we want to append v to it, to this list.
Yeah.
So you will come to v1, self points here, correct?
Yeah.
And then you would check whether this list is empty or not, whether this list contains another element or not. So you would look at self.next. This is next. The self.next, is it none or not? Correct? In this case, it's not none. So what would you have to do? You would have to insert this v in the list starting here. at the second element, correct?
Yeah.
So you would say self dot next dot append v, correct?
Yeah.
And then you would say return, correct?
So, but
And
what
if
if there are, sorry, what if there are like 3 elements? Then you can't do self dot next dot append. Right?
no,
Or no?
you can still do that, because see, let's take an example with 3 elements. You would call this, so there is this v3 and there is this, correct? Sorry. There is this, correct? Now, when you call this at v1, it would go to self.next and append, try to append here, correct? And the same function would be called here, and it would try to append it to the self.next, the next one.
Yeah, yeah, sounds.
And when you reach the end, then this check will fail. Self.next would not be defined. And then you would execute this. And then you say data. Correct?
Yeah. Yeah.
Or another way to write it is if self.next append v else self.next is equal to my list. Correct?
Yeah, yes.
So,
Yeah, tell me.
so our value and next initialized somewhere. Otherwise, I don't understand.
Initialize here.
So you can initialize values of an object in init, and then you can use them.
Yes, yes, that's what init is for. So maybe I underemphasize this. All the values that are in the object, or whichever values you want to initialize, are initialized in the initializer, in the constructor, this init. Correct?
Okay.
So when you call this mylist v, it would put self.value equal to v and self.next equal to none. Correct?
Yes.
So this would do the thing, correct? So this is suppose 1 and we replace it by this, correct? This is slightly cleaner, correct? So do you see the thing?
Yes, sir.
Okay, now you might have, you know what insert does, correct? So append is in this thing is so append adds at the end of the list. If you want to add to the beginning of a list, how will you do that? So you have a list which presumably looks like either either it points to, so let me write the thing here, none comma none, meaning the default value that we have inserted is none. So it's an empty list, correct? So I jumped through a step here, which is to say, what do you want to store in a list? In my list, what are the possible values of my list? You would either store a non-empty list or an empty list. So how is the provision for an empty list? How do we make provision for an empty list? Tell me. So that is through this. So both the value and the next are set to none. So this is an empty list. It doesn't contain a value and there are no values to follow. And suppose we impose the discipline that you cannot have none value followed by a list. correct? So value is none only for an empty list, correct? This is a reasonable convention to follow. Do you agree?
Yeah,
Are you
sir.
with me? Yeah. Okay. So now, with that said, how would you insert in the self a value v? So let's do it, and we will see what the pitfalls are. So let me do it here. And okay, so now how would you define this? So first thing is to check if self dot value, if not self dot value, then what do you do? If the self value is none, then you will just say self dot value equal to v and return. Correct? Else, what would you do? So it has a value, and you want to, so the list looks something like this. It has a value v1, and this points to something. I don't know what it points to. It could be empty or non-empty, whatever. Correct? There is a pointer, and this is what the self is pointing to. Correct? So now you want to insert something between self and this first thing, correct? Inserts at the beginning or the head of the list. Are you with me? Tell me.
Yes, sir.
So how would you do it? Well, the naive way to do it is you would say self dot. So you save the value of self dot next. So you save the value of this pointer. Temp is equal to self dot next. Correct? And no, sorry, you save the value of self. Save the value of self. And you say self is equal to, so you want to point, so is equal to my list v, correct? So you have made self point here, and you save this pointer. This is temp. So this is my first command. This is my second. This points to now v and empty. And then I say self dot next is equal to temp. And then return. So I have put this here. And so in the second one, so this I have, correct? So now tell me, will this work? Tell me, anyone? Sorry. It will not work. Now, can you tell me why it will not work?
When we did temp is equal to self, did we copy self or we just assign the pointer, right? So does that cause problems?
Yes, that causes problems. So the point is that if you analyze this, like you said, outside the structure, self still refers to the same thing. I mean, you have changed the value of self inside, but externally it still point to, so the object still points to the same thing, correct? Sorry. This is what it was pointing to. You have locally changed self, but that won't be reflected outside. You cannot change the value of self and expect it to change outside the thing, correct? You cannot
So-
change self, essentially. Tell me.
No, what do you
I
mean
mean-
outside? I don't think I understood.
Yeah, so good point. So here, let me in the main code. So I say my list L, correct? My list equal to L. No, what am I writing? Sorry. L is equal to my list. L is equal to my list. And then L dot insert 1. This is fine. It would create 1, and this would be set to the empty list, correct? This would just go here and do this part, correct? So first it would, this would create the empty thing. And then this operation would create this. And now you would say L dot insert 0, suppose, correct? So what would happen? You would, in this loop, you would get, the splicing would be fine. You would do this and this, and you would create inside this 0, and this would point here. But when you, this L dot insert would not change the value of self outside. In the main code, it would not change this. So even though the 0 is spliced in, it would not change the value to which this L points. Do you see why?
Because we're changing only the pointers, is that?
We are only changing the pointer. So we have shifted the self pointer here, and it's a local variable inside, but globally it has not changed. Correct?
Okay.
So the value of self cannot be changed globally. It can be changed locally. You can move self around. You can use it as a regular variable, but globally it will not change. It will not, changing the value of self will not reflect outside the function call, outside the method call. So now if we want to insert 0, how should we do that?
So I have a doubt. So you said it doesn't change globally. So does that mean to change the value of self in the init thing? Or, I mean, is that?
Meaning this code doesn't work, correct? The first thing to which L points will remain the same. L will continue to point at this. Even though you have spliced in this, at the beginning, there is nothing pointing to this. L dot insert will not, correct?
Yeah.
So how do you do that? So you would have to do replumbing, what is called replumbing. So how do we do that? Basically, what you will do is you have this list with 1 here, and this points to this, correct? Now what you would do is you would add something here like this, correct? So you would remove this. Instead of adding before 1, you would add after 1, move the value of 1 here, and then add 0. Change the values to 0 here. Do you see my point? So instead of adding in the front of the list, you add after the list and shuffle the values around. You don't, so you can always add after the list, correct? You can do this. So let me write the code. So this part remains the same. And now we say self dot next. We save self dot next in temp. So we have this list as this, and this is the beginning of the list. So we save this in self.next in temp. This is self. This is self.next. This pointer we save, and we do self.next. We change self.next and point it to my list V. Correct? We create a new list and put it here. And then we say self dot next is equal to temp. Correct? So which means we have spliced in this new thing here. And now we have to swap these two values because they are in the wrong order. Correct? This was V1, this was V. So we would say TMP val is equal to V1 is equal to, sorry, self.val, and then we say self.val is equal to V, and then we say self.next, so dot val is equal to temp val. Correct? And if you, yeah. So does this work? Tell me. So we have swapped these two values, V and V1. And this introduces, splices in the new value after the head of list. So am I making sense? This is not the most optimal code. You can certainly, for example, optimize this slightly, correct? So how would you optimize it? Tell me. Hi, are people there?
Yeah, sir.
Yes, sir.
Yeah, so tell me how you would optimize it. You have copied this V twice, correct? So you don't need to do that. You can just say temp is equal to self dot next. You save temp. Self dot next is equal to self dot next is equal to my list temp dot val, whatever value or val, whatever you're calling it, correct? Val. And then you say, then you do the splicing it. Self dot next is equal to temp, correct? And then you just say self dot next dot val equal to v. So this is a shorter version of this.
Sir,
Tell me.
so what have you written, like a little above? Could you go scroll up to me?
Yeah, sure. Tell me.
Yeah. Here. Splices in the new value after the something.
Splices.
Yeah, and after that, like splices in the new value.
After the head of the list.
Okay, head of. Okay.
Correct?
Yes, sir.
Okay. More questions?
So could you say again why the first piece of code didn't work?
This piece, which one?
Yes, this one, sir.
This one, huh?
Yeah.
Why it didn't work was because you have, so what is the best way to explain it? What you do is that so let's see the invocation. When you say L dot insert 0, correct? Self initially points to wherever L was pointing, correct?
Yes, sir.
Whatever was the value was inside L.
Yeah.
Now you cannot change that value inside the function. L would continue to point to the same thing, correct? So L was pointing to this 1, correct? And it would continue. It would continue to point to this 1. You have inside the function, you have added something in the beginning of it. But where have you changed L? So one of the options is you do don't do an in-place change. Instead, construct this list and return this value. Correct? And then say L is equal to L dot insert 0 or something. Correct? But that would be a different function altogether. Correct? It's not an in-place change. If you want an in-place change, then you would have to change the ordering of the these things. Do you agree?
Yes, sir. So this makes sense, but I think I'm confused with at the very beginning when we say temp is equal. When we have the self even.
Yes.
This points to the same thing as L does. Is that
Yes.
right, or is it?
Yes, that's correct.
So if we change that, why does what L points, like L is pointing to the same thing, so why isn't that changing? That I'm not clear about that.
No, so you have self and you have L. Both point to the same thing, correct?
Yes, sir.
To this.
What's changing? Okay.
Now you change self. You change self. It doesn't change L. L still points to the same thing, to the original.
Yes, sir. Yeah.
So thanks for clarifying that. Yeah.
I got it now, sir. Thank you.
Yeah. Is it clear? So self starts pointing to something new, but L continues to point to the old. Correct? and this is like this, and then this is like this. But when you exit this, yeah, this thing is lost, and L just continues to point to this one. Okay, so more questions? So this is often called replumbing. You're changing the pipes around, right? So, changing the connections and so on, or rewiring, whatever. Are there questions? If not, let's.
Sir, can you make these slides available on Moodle? Can you post the lecture notes?
Sure, I will do that. Send me a reminder. Can you do that?
Today.
Whenever you want it to be reposted. I will
No, I mean post it, like, the slides, the lecture.
I will post it today, but send me a reminder.
Okay, sure, sir.
Okay, remind
By
me.
mail.
By mail, yes.
Okay, sure, sir.
And remind me also while you are at it to post the 2 lectures from last week. I forgot to do that. Correct?
Okay.
So I would welcome if somebody reminds me.
Sure, sir.
I will not take it otherwise if you remind me. Correct? So
Yeah, sure, sir.
okay.
So could you scroll down just to the last slide?
Sure.
Okay, yeah. One second. Okay, yeah, sir. Yeah.
Okay.
But just to make sure that I've got it right, what we are doing in this piece of code is to get around the fact that we can't really change L in the method itself. We add in this new node that we want in between in the second place, and then swap the 2 values so that everything. Yeah.
Yes. Yes.
Okay. Okay. Got it, sir. Thank you.
Okay. Thanks. And this is a slightly optimized version of that. I hope it is correct, but you can optimize it slightly, even if it's not correct. Correct?
Yes.
Okay,
sir.
thanks. Okay, thanks. We meet on Thursday. Thanks.
Thank you.
Thank you, sir.
Thank you.